Hello, and welcome to day 5 of Advents of Code 2023. So we're going to jump in, check out the puzzle. All right, let's see. If you give a seed a fertilizer, you take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. A water source. Island is the water source. You point out that Snow Island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't make snow with dirty water. Don't worry, I'm sure we'll get some more sand soon. We only turned off the water a few weeks. Oh no. His face sinks into a look of horrified realization. I've been so busy making sure everyone here has food that I completely forgot to check why we stopped getting more sand. There's a ferry leaving soon that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another. While you wait for the ferry, maybe you can help with our food production problem. The latest Island Almanac just arrived and we're having trouble making sense of it. The almanac lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed, what type of fertilizer you use with each kind of soil, what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number. The numbers are reused by each category, that is, soil 123 and fertilizer 123 aren't necessarily related to each other. So we have puzzle input. Okay, so we have seeds, we have a seed to soil map, a soil to fertilizer map, so on and so forth. And this is a lot of input to parse. The almanac starts by listing which seeds need to be planted. Seeds 79, 14, 55, and 13. Okay, so we need those seeds. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is, the section that starts with a seed to soil map describes how to convert a seed number, the source, to a soil number, the destination. This lets the gardener and his team know which soil to use, with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of numbers that can be converted. Each line within a map contains 3 numbers: the destination range start, source range start, and the range length. Consider again the example seed to soil map. Oh my goodness. Why is there so much text? So we have that, and that, and that. Okay, the first line has a destination range start of 50, a source range start of 98, and a range length of 2. This line means that the source range starts at 98 and contains values 98 and 99. The destination range is the same length, but it starts at 50. So its values are 50 and 51. With this information, you know that the seed number 98 corresponds to soil number 50, and 99 corresponds to soil number 51. The second line means that the source range starts at 50 and contains 48 values. This corresponds to a destination range starting at 52 and also contains 48 values. So seed number 53 corresponds to soil number 55. Okay. Any source numbers that aren't mapped correspond to the same destination number. So the number 10 corresponds to soil number 10. Then the entire list of seed numbers and their corresponding soil numbers looks like this. With this map, you can look up the soil number required for each initial seed number. So 79 corresponds to 81. 14, 55, okay. But the gardener and his team wants to get started as soon as possible, so they'd like to know the closest location that needs a seed. Using these maps, find the lowest location number that corresponds to any of the initial seeds. To do this, you'll need to convert each seed number through other categories until you find its corresponding location number. In this example, corresponding types are Seed, soil, fertilizer, water, light, temperature, humidity, location. Oh my goodness. So the lowest location number in this example is 35. What is the lowest? Okay. This is a mouthful. Goodness gracious. All right. So these go up by 2. There's just so much to digest at once. Destination range start of 50. Source range starts at 98. Source range starts at 98 and contains the two values 98, 99, and those get mapped to 50 and 51. So 50 to 52. Okay, hold on. Source range starts at 98 with a range length of 2. And then there's a second line that says starting at 50, the next 48 numbers get mapped to 52, 53, so on. Okay. So 15, 0 to 15, 52, up to 54. Do these go all the way up to 99? I'm guessing so. Okay. So okay. So that's a good start. We've got our list of seeds. So seed to soil map. So equals x in info if x not equal to law. I don't know how to do the string comprehension thing or the list comprehension thing. How does one do that? X for x in info if x not. I think this is it. It's not quite what I was expecting. Yeah. We finished the problem already? Probably needs to be in the X. I'm just not. Let's see. I know what I'm trying to do, but it's not working the way I'm thinking I want it to. Trying to just delete the whoops. Oh. No, this is what I want. I'm printing the wrong damn thing. There we go. Okay, that's exactly what I wanted. Just wasn't printing the correct thing. Okay. But how do I want to parse this? Let's see. So what's the format? It's here. How about we just do this? So for maps equals some dictionary. If item okay, cool. So basically I'm starting with just grabbing these strings because they all end with a colon and everything else is just numbers. So then maps at item equals let's just do an empty list. And we'll we'll say current map equals item. Else maps at current map. Doesn't matter, but makes more sense in my head. Dot append item. And this isn't formatted quite how I want it, but I want to see if this is what I'm thinking. For key value in maps print. Why do you do this at midnight every night? Because that's when the problem releases. The problem, so it's an advent calendar. So the problem releases at midnight Eastern. That's just by design of the creator. I don't remember my dictionary commands. I also can't type. Oh my goodness. Print key maps. Key. Okay. So like I could wait till later in the day to do this, but it's more exciting to do it when the problem comes out. Okay, so instead of appending it as this, I want to map the alien creator. Thank you very much for the follow. Welcome in. Map info equals item dot split print map info. Is this Unreal 5? I'm not sure what that is. This is Advent of Code. Okay. I was gonna store these as tuples. No, this is just PyCharm. This is Python code. We're programming. We're solving a puzzle with Python. Here. I need a button for that. That gives you a little bit more information about what's going on. Answer is 63. Not quite. I don't know if there's a nice way to go from list to tuple. Okay. I think I'm pretty much parsed into the way I want it to. Maybe. Unsure. So now we have to think about figure out how to set up these maps in a way that makes sense. I hate that it's source destination. It's backwards from the way I would think about it. So how do I want to break this up? So 58 up to 98, not including 98, it's mapped to 52 to 90, 100, not including 100. The problem is figuring out how to set up the identity map. Or how to set up these maps at all. Not sure how to store this in a way that makes sense. So we have different ranges. So this first thing here says that everything from range 98 to 98 plus 2 gets mapped to the range 50 to 50 plus 2. And this says that the range 50 to 50 plus 48 it's mapped to. So I just have a bunch of piecewise functions. 52 to 52 plus 48, and then else identity map. How do we programmatically set up these like piecewise functions? I could check to see if my input is in this range, then it's mapped to that. So '98's mapped to 50, right? And 99 is mapped to 51. So it's how far from you are from how far are you from the starting point of the range? Okay. Let's see. Okay, I have an idea. It's gonna be kind of messy, but I have an idea. I'm just gonna create my map function. I just need to figure out how to store it. So, like, imagine we have a dictionary. What's the first one called? Feed to soil. Imagine we have a dictionary. And the dictionary literally just takes the, so we can go for I in range 98 to 98 plus 2. D at I equals 50 plus I. And then for I in range 50 to 50 plus 48, D at I is going to be equal to 52 plus I. And so then we can just say prints, D at 99. And it should print out. Nope, this isn't what I want. I want minus the starting number off by 1 error question mark. No. Okay. And then print D at, I don't know, 53. It's 55. Do a smaller number. Yeah. So then I could say, I could say if I in D dot keys, then print D at I, and if not, just print I. And so I have, 50 gives me 52, but if I punch in 45, then it should just give me the identity map. So then we just need to populate all of these. So we have a bunch of different maps. Those themselves are dictionaries, and I want them to be inside of dictionaries. So for map type in maps.keys. Print map type. Okay. So for range map in maps map type print range map. So these are the things. Okay, now that I've got a grip on the problem, I think this is actually this isn't going to, I think, fingers crossed. So we need to construct the explicit maps equals a dictionary. And we're going to how do I want to, yeah, map type equals an empty dictionary. So we're gonna have a dictionary of dictionaries. Basically, I'm thinking of like I have like a map, like a little literal map object inside of a dictionary. So like the sub dictionaries, I'm thinking of them as just map objects. So we have this thing to look at. We need to construct this. So for I in range map at 1 up to here. Let's add some variables to this. Source start equals range map at 1. Destination start equals range map at 0. And then length equals range map at 2. So for I in range source start to source start plus length explicit maps. It's a good thing I got part 1 on the first try. I'm jealous you already have it figured out. It took me forever to logic my way into this, but I think I'm getting there. One of these days I'll be as smart as all of you. Lost my train of thought. Equals destination start plus I minus source start. So I'm making a map of maps, just if you're curious. And I think I have it or not. Everything is a string. Uh-oh. Why are you saying uh-oh? Artie's not looking trivial. Wonderful. I hope this method of solving today's part 1 is in spirit of what you were trying to instill on me the other day. So, well, I'm talking about like in terms of storing the information in a more like algorithmic approach, like storing the data in a way that's, you know, that you can attack with an algorithm or something like that. I don't know. Maybe I'm completely missing the mark. So for key and explicit maps dot keys, value equals Okay. If value in map dot keys value equals map at value, else well, there's really not even an else, it's just identities. String object has no blah. String index out of range. Let me think about this for a second. So here, let's just start over. Print map key. There should be these strings, correct? Print there should be a dictionary, correct? So this I want to be equal to my map function. If are these all no. If value in map function dot keys value equals map function at value. Okay. $81, $81, $81, $74, $78, $78, $82. Cool. Okay. I think I figured it out. So then we're looking at all of the seeds and we want the one with the lowest location. For seed and seeds. What am I doing? This should be seed. Oh, here. I'll do it this way. Value equals int seed. So I think it's a string right now. Location min equals min. Location min and value. I think this is just gonna be 101. Okay. What does my puzzle input look like? Oh. The numbers are a lot bigger. Got it. Is that gonna make this like impossibly? It's probably gonna make this unwieldy. The my solution's probably trash. Damn, I thought I had such a good idea. How many seeds are there? Not a ton. That sucks. This brute force sort of approach wasn't any good. Alright, rather than constructing the map, stick these range pupils. Let's see. All right. Can we do our logic without building the explicit? Oh, it terminated. Did I kill it? It didn't print an answer. What is that? What does that mean? Fatal error? Okay. It said nope. Not today. All right. So this is basically no good. Let's go back to this. So we could... All right, let's make a function. Evaluate over map. And call it X. Value, whatever. And map. So for item in for map range and map function, we're gonna pass in this listing. if value input if the value input is here, we'll do this again. Let's give it some nice variable names so it's easier to think about. Okay. So if value input is less than or equal to source start and less than source start plus length. Return that. Memory error. I had a weird error. I had this. I've never seen that before in my life. So let's test this function. Evaluate over map. No, my part one was too brute forced too much, I suppose is the best way to describe it. M equals maps at blah. I think I'm gonna get there soon. Okay, so print evaluate over map M number first, 50 and M 52. Yeah. Okay. So we want to do what? For map key in maps.keys. We want map function equals maps at map key. Value equals evaluate over map value map function. this is right. Such a good feeling. Everyone will starve if you only plant such a small number of seeds. Reading the almanac, it looks like the seeds actually describes a range of seeds. The value of the initial seeds line come in pairs. Within each pair, the first is the start of the range and the second value is the length of the range. So the first line of the example above, the first line describes two ranges of seed numbers. 79 and contains 14 values, 55. Now, rather than considering 4, you need to, the above example, the lowest location can be obtained by from seed 82. Consider all the ranges. Why isn't 35 the lowest this time? 82. Oh, because 13 was a range. Okay. This might not be bad. Maybe. I'm guessing there's just an unwieldy number of seats. Couldn't even load all the numbers, seed numbers in. I guess it's at the end of the world. Well, I'm not sure like how I would, so like, it seems like that part 2 isn't like your solution for part 1. Like handling the size problem isn't a part 1 problem per se, if that makes sense. Like, is there a way to, like, is there a way for you to not do all the computations? And I'm not sure. All right, let's try some stuff. Or oh, that was this answer done. Okay, I was like, where did that come from? So I'm just trying to get a, how's the saying go? Trying to get my bearings, something like that. That's where I'm at right now. So this is 79 to 92 and 55 to 67. Okay. This is that. That's working. Um, why is that not working? Okay, can I not spell? No, that's fine. Okay, so my logic is right. Well, maybe. Problem is my code going to be able to run this? And I'm going to guess the answer is no. And I'm not sure how to optimize this, because I'm just doing way too many computations. Like a ton of computation. I have an exam in 7 hours. We might have to put part 2 on pause. Because I'm just not even sure. Like I feel like what we have is pretty good in terms of like our tools. So we have, you know, all of our parsing. Then I have a function that takes in, you know, whatever number in your map function, and it you know, it does the math. It does the mapping of like, I map, you know, my input to whatever output. Basically I look at, okay, well, there are a bunch of different ranges, and I check to see if my number is within the range that I'm working with, and then do the mapping. And then if it's not in any of those ranges, then do the identity map. Then I have this function that says start with your seed and go through and do all of the maps. So there's a bunch of different maps going from seed to soil to fertilizer to water to light to temperature to humidity to location. And so I'm performing all of those maps. The bottleneck is I have to do all of this too many times, because the big data set has a huge number of seeds, a huge number of starting points. And I'm trying to find the smallest final output for all of those input. And I'm not sure how to optimize this so that I'm not doing all of the computation. I'm gonna think about it for a few more minutes, and if nothing comes to me right away, I think we'll put part 2 on pause and pick up after I sleep. Let's Is there any like additional information we could whoops, there's my code. Is there any additional information we could sort of grab without doing the work? Can we skip some maps? Can we... How big was my answer? For part 2? I don't have an answer for part 2. My code won't even terminate. Oh, for part 1. One, 2, 3, 4, 5, 6, 7, 8. Yeah, 3 to the 8. I'm wondering if I can... I'm wondering if there's a way that I can get some information out of, once I know something like the endpoints, if I could interpret some information about what happens in the middle. The problem is I don't know if, because none of these maps they don't have any nice, like, increasing, decreasing sort of properties and things like that. Each interval is just x plus a. Yeah, but you don't know... Like, I'm talking about, like, as, like, one big function that does all the maps successively. Like if I'm just looking at this one range of seeds. I'm not sure. I think we need to not push the envelope on this one tonight, because I do have to get some sleep. So yeah, we'll stop here and pick back up sometime tomorrow afternoon, or today afternoon, because I have an exam. I have an exam at 8 a.m., which is in less than 7 hours from now. So I need to get some sleep. At least 6 hours of sleep. And then go from there. So thanks everyone for hanging out as we started day 5 of Advents of Code. We got through part 1 without much trouble after we kind of cleaned up our approach on how to work through the maps and such. But part 2 is giving us some trouble. We need to come up with a way to not do all the computations and come up with some sort of way of just minimizing that number of work. So there'll be a second part to this video, hopefully in the next 24 hours. We'll see. It depends on how much trouble the problem gives me. So thanks again. Hope you all have a great rest of your December 5th, and I will see you all next time. Take care.